Tweedledum, Tweedledee. Oh, nice of you to come by. What are you two up to today? Wrongifying. Tell me what on earth wrongifying is. Eating an orange and peeling it. Ah, Rose, okay. Right. Aha, yes. Okay, I think I understand. Numbers also have the ability to wrongify. For example, let's say 8 minus 5. If that's what you want to say, but instead you say 5 minus 8, well then you've just wrongified yourself, haven't you? Okay, so that's actually true. It's not the numbers, is it? Because, yes, 8 plus 5, so it's not the numbers that are wrongifying. It must be the operators. So plus is an operator that doesn't wrongify. Yeah, and minus and division, that's right, because 8/5 is not the same as 5/8. So those two are wrongifying operators, if you like. But this is only for the commutative property of our number system. So yeah, commutative. Yes, Tweedledum, actually there is another way. We could use the associative property of mathematics incorrectly. We could use it for subtraction. So let's see. Is that going to work? 60 minus 6 minus 2. Do we mean 60 minus 6 and then minus 2? Or do we mean 60 minus 6 minus 2? Because those are going to come up with two different answers, 56 or 52. Tweedledee, what do you mean? No, just let's say that we've wrongified the situation. Let's move on. Let's look at division. So 60 divided by 6 divided by 2. Is that unambiguous, or do we have a problem? Yeah, it depends on how we're grouping those first. Which ones are we doing first? Are we doing 60 divided by 6 and then divide the result by 2? Or are we doing 60 divided by 6 divided by 2? So in one case, we're going to end up with 5. Thank you, Tweedledee. Yes, it's very different. Yeah, we've wrongified successfully. That's right. It's the subtraction and the division that doesn't work associatively. So that's what you want if you want to play this wrongifying game that you guys are up to. Yes, associative wrongifying. You guys should also think about the distributive property. So yeah, distributive. So the distributive property is, in our number system, is 2 times 3 plus 4. And that is actually equal to 2 times 3 plus 2 times 4. Okay? And you can see that in both cases, that's equal to 14. I understand, Tweedledee. Now I'm going to show you that for any other choice of two operations, the distributive law doesn't work. Okay, so for example, yes, Tweedledum, we can try subtraction and division again. Let's take 8 minus 4 divided by 2. Is that the same as 8 minus 4 divided by 8 minus 2? Think about it. I think you're going to come up with, yeah, 4/6 and 6. That's right. So those are two very different results. And I'm glad you guys are much happier, you wrongifiers. Before we leave this topic of wrongification, you guys should understand a really common way that people mess up and that's by not agreeing to the order of operations. Yeah, the order of operations. So how do you calculate something if you're given an equation? No, that is one way of doing it, but that's not the standard way that we go for. We don't usually calculate things left to right. So for example, if we had 4 plus 3 squared, if we calculated left to right, well then we would go 4 plus 3 and then squared it. But that's not the standard way that we do things. We actually, the standard way is 4 plus and then 3 squared. So we do the 3 squared first. So you should Google order of operations just to clarify which ones come first. there's nothing to say that that's the way that has to be the way it is. Like, you can decide, if you get a group of people together, oh, I'm going to go starting at the right and calculate all the way to the left first. So anything's possible, but you just have to agree with the other people that you're communicating with. Otherwise, errors will happen. So let's keep on going here. That is 7 squared on the left, and on the right we have 4 plus 3 squared. So we're going to end up with 49 compared to 13, just because we haven't agreed on the order of operations. Another example, 4 times 3 squared. Is that equal to 4 times 3, then squared, or is it equal to 4 times 3 squared? Well, the standard way is to do the exponent first and then do the multiplication. So the 36 is the standard answer for this. Now, Tweedledum and Tweedledee, it is time for us to play a game. And this is going to be a game that's going to test your order of operations. So remember to Google it before you start the game. I'm on level 1. Sam has the equation a times b plus c. So I have to scoot around. I'm going to pick up the 10, the 5, and the 2. That's 10 times 5 plus 2, that's 52. And I'm going to use that to get rid of that 52. Got it. Okay, now I want to get to 20. So I'm going to go 2 times 5, that's 10, plus 10 will get me to 20. Lastly, I want to get to 25. That's going to be 10 times 2 plus 5. I'm going to get to 25. Got it. I'm on level 2. I have to deal with negative numbers now. And my equation is a plus b times c. How am I going to get to 96? I'm going to take minus 4 plus 10 times 10. So that's minus 4 plus 10 times 10. That's going to be 96. Fire. How am I going to get to minus 30? Well, that's going to be... how do I get to minus 30? That's going to be 10. So I have to add on 10 first of all. And then I'm going to go minus 4 times 10. Ah! There before me. So that's minus 4 times minus 4. That's 16 plus 10. That's 26. Oh, by pure luck, I have got 26. Okay, let's see. Fire. Got it. Now, I'm going to enact my old strategy of getting to minus 30. I want 10 plus minus 4 times 10. So that should get me to minus 30. Fire. Got it. See how it works? Enjoy.